Hi everyone, so today I'm going to be teaching you how to plot a sine function on a graph. So this right here is your sine equation, and this is just the equation of a sine graph. And in this graph there are various different variables. So you have your A variable, your K variable, your C variable, and D variable. Your A variable is your amplitude, and all that really means is that it's the y scale of your sine graph. So if the amplitude increases, your y-axis would increase. All right. So your k value is your periodic shift, and this variable is kind of tricky because you actually need to do some algebra to solve it. The equation that you would need is 2 pi over k. So as you can see right here, I had already outlined that. But 2 pi over k is going to be your variable. So if that's just going to really tell you if you're going to horizontally compress or expand your function. So your C variable is your phase shift, and all that really means is how many radians you're either going to move it left or right. So if you had a phase shift of pi over 2, you would just move your equation over pi over 2 radians. And your vertical shift is just how far up the y scale or y-axis you're going to be moving your function. So if you had a vertical shift of 1, you would just move your function up 1. All right, I hope that helped. So now we're going to try to plot our own function. So my function is y equals 2 sine times of 2 times x minus pi over 2 plus 1. So as you can see, this function has an amplitude of 2. So what we're going to be doing is we're just going to be increasing our y scales. As you can see, I've already done that. So our y scale is now -2 to 2. So let's just go ahead and replot that standard sine function, but this time our major and minor points are going to start and end at 2. All right. So as you can see, compared to our basic sine graph, this isn't much different. All we did was just increase the y scale, so it's a little bit more vertically large than the other one. This had an amplitude of 1. This has an amplitude of 2. That's the only difference we've done so far. All right, so next we need to change our period. So this equation has a k value of 2. And I said before that our equation to find the period is 2 pi over k, which is in this case 2. So our new period is equal to pi. All right. So since our new period is equal to pi, that just means that we're going to have to fit our sine function between 0 and pi radians. And then it's going to repeat again. So what we need to do now is we're going to start again right here, plot our point at 0, 1, 2, that's our amplitude again, 1, 2, amplitude. So we already plotted a point at 0. Now we're going to plot a point right here, halfway between pi 2 and 0, which is about pi over 4. So this is just really because we have to fit this whole sine function in this space right here. Let's go ahead and finish plotting the rest of our points. So that is basically changing our period. So as you can see here, we had a period of 2 pi, so it repeated every 2 pi radians. But down here, since our new period was pi, we had to compress it, horizontally compress it into a space of pi. So our next move is our phase shift. So like I said, our phase shift is just how far over horizontally we're moving our function. So we had said that our phase shift in this equation is minus pi over 2. So that just means we're going to be moving our function to the right pi over 2. So we're going to start right here, our first point at pi over 2. And like I said, gotta draw our amplitude. Draw a point right here, 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 and here. Alright, so now we have our vertical shift, which in this equation is 1. And so all that basically means we're just going to be moving our whole function up by 1. So this is going to kind of mess with our y-axis a little bit in the sense that we're going to have to create a new line here, which just means that our amplitude isn't going to increase, but it just means that it's going to have a new roof at 3. So let's go ahead and plot our points. As you can see, this moved up 1. 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 Alright, so as you can see, everything, all we did was just move it up by 1. So really nothing has changed. Our period is still pi. Our amplitude, although it's shifted slightly, all it's done is move up by 1. And that's pretty much it. All we did was just move the sine function up 1. So as you can tell, this is our final sine function. This was our original. So it looks pretty different, but I hope these steps have helped you guys to learn how to plot a sine function on a graph.